Good afternoon, everyone. Good afternoon, everyone. Welcome to KSA. Welcome to Space Club. Welcome to the webinar. We look forward to having a very fun session as we talk about something called cube satellites, or short form of cube satellites. My name is Joanne Tanin. Good to see a number of familiar names that have been with us in the beginning of the year. Yeah, it's quite an honor to see you again. So just an overview of who is KSA, who is Space Club, why do we do the webinars? So for those who have not heard, or for those first time being here, KSA in full is basically Kenya Space Agency, and our mandate is to promote, coordinate, and regulate space-related activities in the country. Yeah, and in promoting space-related activities in the country, one thing that we look at is how can we develop capacity in space-related careers, also that we have more professions doing something related to space. How are we going to develop our space ecosystem? And that's why we have the webinars that we are doing, the one that we are doing today. So apart from the webinar that we do on majorly last Saturday of the month, we also do outreach, which is where we attend events where it's STEM related, or schools that are hosting STEM related events. We come with our personnel, we come with our experts, you have a chat with them, and also have experience some hands-on activities such as water rocket, robotics. Yeah, we have a session with planetarium, which provides some immersive learning in space science, and also space systems engineering. Yeah, that is in a nutshell Space Club. Other than that, we try to disseminate the knowledge, or rather, I would say the knowledge to the public in a way that they can understand. Even though you didn't do engineering, even though you didn't do maybe GIS, you can still understand what is space. Yeah, so we write books, or rather we do literacy materials for upper primary. Yeah. So far we've done module 1 in engineering, IT, space science, and Earth observation. Earth observation is GIS remote sensing related. Other than that, as Space Club, we do something called Globe. I don't know if you've heard of it. Yeah, Globe is like an international program. Yeah, but KSA is in charge of implementing it in Kenya. So Globe in full is global learning and observation to benefit the environment. So we collect data related to the environment, talk of humidity, talk of temperature, talk of rainfall, talk of what else? Talk of wind speed, all that. So what we do is, if you're interested, we set up like, can you call it an infrastructure in your school where you can collect the data and you can use the data to do your own projects. And if you want to participate in it, there's always an international participation where everyone is invited, a team from each school, where you come up with a concept note, you come up with a project, and then using the same data that you collected from your school. And if your project is picked, then you keep going in the stages of, I'll say, the competition. Yes, so in a nutshell, that's Space Club. So yeah, and today the webinar we're going to look at something called CubeSats. I don't know how many of you have heard of it, or yeah, you've heard of a satellite. Yeah, so CubeSat is basically a small satellite. Yeah, so we're going to hear how is it classified? How do you distinguish between the sizes? Maybe the description of what indeed is a CubeSat payload. Yeah, all those things. We're going to hear them today, and we have someone who is an expert in that area going to take us through. So I'm going to invite Evans, who is my colleague, to talk to us about CubeSats. Yeah, and hear more about how are we utilizing that technology as Kenya. All right, over to you, Evans. Karibu.
Is it on? Can you hear me? Hi, I hope you can hear me. My name is Evans Yung Kidada. I'm an engineer at Kenya Space Agency. I've been blessed with this task to show you about CubeSats, and kindly give me a minute as I share my slide.
Apologies about the technical issue we're experiencing. Maybe as we wait for for that to be sorted, maybe can make it like an open session just to hear from you. What are your expectations? And if you've been with us in the other webinars, yeah, what comment, what highlight, what is your highlight for all the webinars and maybe today? What are you looking forward to? Yeah, I'll do like a random picking. Yeah, before we hear the presentation. There's Faith. Yeah, Faith was here early. Can you just unmute and say something? We also want to hear your voice. Okay, okay. Thank you there. Yes, thank you. Say something.
So we were with you, but in our webinar that was held much later. I mean earlier, and but if you've done some after that, then we haven't exactly been there, but we've taken this opportunity to come and join this webinar, and we look forward to learning about what you're going to instruct us.
Okay, okay. Thank you, Faith. Yeah, so I think the presentation is up. If you have any questions as the presenter is doing his presentation, please do not hesitate to raise your hand. Yeah, if you feel you want to raise your hand, please drop it in the chat. There will be someone to help you out and answer your question. Okay. Over to you, Evans.
Hello, I hope you can hear me. Hello, can you hear me?
Yes, yes.
Okay. Thank you. Sorry about that. So CubeSats, in today's webinar, we'll dive into the world of CubeSats. We'll learn how these little satellites are built, how they get into space, and what they do once they're there. We'll look at some of the real-life CubeSats, see how they are helping scientists, engineers solve space mysteries, and get ready to discover the fun and exciting world of CubeSats. Next, so we are going to go through overview of what our webinar will be. We'll zoom into CubeSats. They are small, tiny boxes that do big jobs. They help scientists learn more about space and Earth. We'll check out the parts of a CubeSat, the solar panels that catch sunlight, batteries to store power, and special tools to talk to Earth. Then we'll learn how to launch CubeSats into space. And finally, we'll see Kenyan-made CubeSats. Kenya has made its own space boxes, and they are doing awesome things in space. So join us. Welcome, and I hope you enjoy this presentation. A satellite is something that moves around a planet or a star. Earth goes around the sun, so Earth is a satellite of the sun. The moon goes around the Earth, the moon is an Earth satellite. There are two types of satellites. the natural satellites and artificial satellites. Natural satellites are like the moon, which aren't made by people. Artificial satellites are machines made by humans and sent into space to orbit Earth or other planets. These artificial satellites help us with things like TV, weather, even finding our way using GPS. We go on to the next one. Classification of satellites according to weight. A satellite is a man-made object that's sent to do specific jobs. For example, satellites can help with phone calls, weather forecasts, and GPS directions. These are different kinds of satellites based on their size and weight. Tiny satellites are very small, like a book. They weigh between 0.1 kilograms and 1 kilogram. Small satellites are about the size of a suitcase. They weigh between 1 kilograms and 10 kilograms. Medium satellites, they're big as a washing machine. They weigh between 10 kilograms and 100 kilograms. Large satellites, these are about the size of a car. They weigh between 100 kilograms and 500 kilograms. Very large satellites, these are like a big truck. They weigh between 500 kilograms and 1,000 kilograms. Huge satellites, these are even bigger, like a bus. They weigh between 1,000 kilograms and 2,500 kilograms. Gigantic satellites are even bigger than small airplanes. They weigh more than 2,500 kilograms. Each type of satellite has a different job and size, just like how different tools are used for different tasks. There's also application by application, classification of satellites by application. Satellites help in many ways. Just like different tools help us at home, this is what different types of satellites do. Communication satellites. These are like big phones in the sky. They help us talk on the phone, use the internet, watch TV. Weather satellites are like weather reporters in space. They watch clouds, track storms, help us know if it will be sunny or rainy. Navigation satellites, these help us find our way, just like a map. They help our phones and cars tell us where to go and what time it is. Earth observation satellites are like space cameras. They take pictures of Earth to help us see how land and nature are changing, and to watch for disasters like floods or fires. Scientific satellites, these are like space scientists. They study things in space, like stars and planets, and help us learn new things about the universe. Military satellites are like secret agents in space. They help us keep us safe by watching for important information and communicating securely. Technology demonstration satellites, these are like test robots. They try out new ideas and technology in space to see if they work. Space exploration satellites, these are like space explorers. They travel to other planets and moons to learn more about them, like sending robots to Mars. CubeSats satellites CubeSats are tiny satellites made up of small cube-shaped blocks. They can be different sizes, like 1 block, 2 blocks, 3 blocks, or 6 blocks. These sizes help us know how big and how heavy CubeSats are, which affects how they are launched into space and how they move once they are there. But no matter the size, all CubeSats are used for one main job: do science or collect important information. Types of CubeSats. A CubeSat is a small box-shaped satellite used in space. It's like a tiny space robot that can do different jobs. They're very handy because they are small and not too heavy, which makes them easier, cheaper to send to space. CubeSats come in different sizes, just like toys can come in different sizes. One new CubeSat. These are like small toy block. It is a tiny cube that is 10 centimeters on each side, like a big dice. 2U CubeSat is like one of those small toy blocks stacked on top of each other. It's a bit taller. It's still 10 centimeters wide and 20 centimeters tall. 3U CubeSat is like a 3 small toy blocks stacked up. It's 10 centimeters wide and 30 centimeters tall, making it even taller. 6U CubeSat is like one of those toy blocks stacked up. It's 10 centimeters wide and 60 centimeters tall. So it's pretty tall and can carry more tools and do more jobs. Each size can carry different tools and different tasks in space, making them very useful for various missions. So what goes into designing a CubeSat? The main reason we go to space is always determined by the payload. The payload is the main equipment a satellite needs to do its job. Think of it as a special tool or instrument a satellite carries to complete its mission. Here's what you might find in different types of satellites. Scientific instruments. Their tools help scientists learn about space or the Earth. For example, they might measure the Earth's weather and study distant stars. Communication equipment, these are used in satellites to help with TV, internet, or radio. For instance, satellites with equipment will make sure you can watch your favorite show or TV or browse the web on your computer. Telescopes, these help in faraway objects in space. Just like a telescope you might use to look at the stars, space telescope can see different distant planets and galaxies. Cameras, these are used to take pictures of the Earth or space. For example, they can help take pictures of weather patterns or monitor natural disasters. Other specialized equipment, depending on the mission, a satellite can carry special tools for unique tasks, like measuring pollution levels or testing new technology. The satellite bus is like the body of the spacecraft. It makes sure everything works and stays safe in space. The payload is the toolbox that does the special task or experiments the satellite was designed for. Together, they help the satellite achieve its goals in space. Power systems. A power system on a CubeSat is like like solar powered. The CubeSat has solar panels which are used to catch sunlight and turn calculators. When the CubeSat is in space, solar panels catch sunlight and use it to make power. The power is then stored in batteries, just like how you use batteries to keep your toys running. And when they are not plugged in, if you have a toy that needs batteries, the batteries store energy so you can play with it later. Similarly, the CubeSat uses its batteries to keep its systems running, even when it's not getting sunlight. So the solar panels give the CubeSat power and the batteries store it. Thermal control. Thermal control for a CubeSat is like wearing the right clothes to stay comfortable. In space, the CubeSat can get really hot or really cold because there's no air to keep the temperature just right. To handle this, the CubeSat has special tools to keep it from getting too cold or too hot. Think about how we can wear a warm coat when it's cold outside or a light shirt when it's hot. CubeSat has a similar tool like blankets or heaters to stay at the right temperature. The blankets are like your coat, keeping the heat when it's cold, while the heaters keep the CubeSat warm. When it's hot, the CubeSat uses special parts to cool down, kind of like how you might drink water or find shade when it's very hot. So thermal controls help the CubeSat stay in a perfect temperature in space, just like how your clothes help you to stay comfortable in different weather. Communication. Communication for a CubeSat is like how you use a walkie-talkie or a phone to talk to your friends. The CubeSat has special radios that can help to send receive messages to and from Earth. Just like you press a button on a walkie-talkie to talk, the CubeSat uses its radios to send information. When you text or call someone, your phone sends your message through the air to your friend's phone. The CubeSat does the same thing, but sends messages to a big dish or an antenna on Earth. If you want to share a picture or ask a question, your phone sends information through the radio waves. CubeSat sends back information about what it's doing, like pictures of space or data about its experiments. So the CubeSat's radios help it to talk to people on Earth, just like you use your phone to talk to your friends. Structural system. A spacecraft structural system is like our skeleton. The structure is made of strong materials that hold everything together, kind of like how our bones keep our body in shape. Just like our skeleton supports our muscles and organs, spatial structure supports its parts like the engines and solar panels. Think about how your bones protect your bones, your organs, like how your rib cage shields your heart and lungs. Spatial structure does something similar by keeping its important parts safe from space and strong enough to handle space travel. If you stand up straight or lift something heavy, your bones keep you stable and strong. Similarly, the spatial structure ensures it stays in the right shape and can handle the stress of space. So just like your skeleton supports your body, the spatial structure supports and protects everything inside it. Onboard computer and data handling. This is the CubeSat's brain. Think of your spaceship as a robot that needs to make decisions. The onboard computer is like your brain. It tells your body what to do. For example, if you touch something hot, your brain quickly tells you your hand to pull away. Onboard computer does something similar. Gets information from sensors, just like how you get signals from your eyes and ears. The onboard computer then makes decisions based on this information, just like your brain decides how to move or react. It might tell the spacecraft to change direction or take pictures. Just like your brain helps you do things, stay safe, onboard computer helps the spacecraft do its job and stay on track in space. Attitude control system. An attitude control system in a spacecraft is like how we stay balanced and move. Think of a spaceship as a toy that needs to point in the right direction. In space, the spaceship has special tools that tell you where it's pointing, like a compass and sensors. These tools are like your eyes and inner ears, which help us know where we are and stay upright. To change direction, the spaceship uses small engines or wheels, like how we move our muscle to turn or balance. For example, when you want to look at something, you turn your head and adjust your body. The spaceship does something similar by using its tools and wheels to change its directions. So, just like you use your eyes and muscles to stay balanced and look around, the spaceship uses sensors and engines to stay in its right position in space. And this is one thing I thought it was important for us to learn, deployers and ride shares. The deployer is a special container that holds the CubeSat and connects it to the rocket or the launch vehicle. That will take it into space. CubeSats get to space in two cool ways. One special box called a ride share rocket or catching a ride on the International Space Station. First, the ride share. Ride share in space means that different satellites share the same rocket to get to space. Instead of one rocket carrying just one satellite, it carries many, like a bus carrying passengers. This way, all satellites can get to space together, saving time and resources. When the rocket blasts off, it carries the CubeSats into space. Once the rocket is in space, the deployers opens up and the CubeSats come out. Second, CubeSat can also get to space through the help of astronauts on the International Space Station. The International Space Station is a big space station where astronauts live and work. Sometimes CubeSats are sent up with support could not end until we mention our special CubeSat, which is TAIFA 1. TAIFA 1 is a big mission and it was a big step for Kenya's space program and has a lot of cool features that help us learn about our planet and our country, Kenya. Here are simple ways to understand it. What is TAIFA 1? TAIFA 1 is a small satellite 6U, about the size of a small suitcase, and weighs about 4 kilograms. It's a nano satellite because it's small, but has a lot of important features on it. These satellites help us understand what's happening on Earth. How does it work? TAIFA 1 was launched into space by a rocket, SpaceX, which carried it up high into the sky. Once it was far enough from the Earth, the rocket let it go to space. The satellite orbits about 500 kilometers up in space above the Earth's surface. That's high enough to see details on the ground like roads, buildings, and forests. The satellite has a special camera that can take pictures in 6 different types of lights. This includes visible light, and which we can see with our eyes, and infrared light, which lets us see things that are too cold, or too hot. TAIFA 1 goes around the Earth in a special orbit that makes it pass over the same area every day. This is a sun-synchronous orbit. This helps us see changes like how field is growing or how flood is spreading during flooding. How was TAIFA 1 built? Kenyan engineers from Kenya Space Agency, engineers figured out that satellites needed to do something in space, and Kenya needed a satellite to monitor the country. And they decided that some similar or some special type of camera was necessary, and it was important to know how we can operate it and how we can use it. When it comes to designing, they created a plan for how the satellite will work and look. And I was part of the team, and we settled that on 6U because that was small enough and also we could afford it. They chose parts and put everything together. Oh, it was a 3U. I apologize for that. TAIFA 1 is a 3U. The satellite was built with different parts like the power system, the solar panels and batteries, the way to keep it right temperature, and equip the equipment to communicate to Earth. Testing. Before it was launched, engineers had to test the satellite to make sure it will work properly in space. After testing was done and it was achieved by Kenyan engineers, the satellite was put in a special container called a deployer. And sadly, Kenya doesn't have the necessary precision engineering to do this. So we give it to other third vendors who also give it to SpaceX. And that's how it's launched into space. When the rocket reached space, the deployer let go of TAIFA 1 and it started its mission. Another special satellite by TAIFA 1 was one Kunz PF. This was the first satellite we had made. So this was just a technology demonstration that Kenyan engineers can launch a satellite to space, and we were proud of it. And I thought a special mention should come into the presentation. And we go to the next section of our presentation. We hope you can make your own CubeSats So before the engineers had to launch the satellites to space, they had to build their own CubeSat prototype. The image shows two engineers, Kenyan engineers, building a prototype of Taifa 1. And that's how a 3U look like. That's exactly how Taifa 1 looks like. So we were really proud to be part of this team here at KSA, Kenya Space Agency. And here is a presentation that helps you build your own CubeSats at home.
Excuse me, are we required to make the CubeSats?
It's not a requirement, but it's a fun activity you can enjoy.
Okay.
Can I ask, can you hear any sound from the presentation?
No, not at the moment, but
At the video.
From the
Okay.
video, I'm not hearing any sound, but it seems. But now it's hung. It's not moving. That is on my screen.
Let me try that.
Mbona imekataa?
Okay, as we try to sort out the video, there's a poll that has been.
Having learned about CubeSat Lite. Hello, having learned about CubeSat Lite, today we are going to model the structure subsystem of a CubeSat Lite. So your final product would look like this, okay? So what are the materials that you require for you to be able to build the structure of a CubeSat Lite? The first material is a cardboard. So you will need to have a cardboard, okay, a bigger size cardboard. And then you'll also need to have aluminum foil. Then you'll also need to have A4 sheet paper or A4 sheet paper. And then you'll also need to have a straw, okay, straw that we normally use to take our sodas. Then you'll also need to have a ruler or a measuring tape. A ruler is okay for students. You also need to have a scissors, okay. Make sure you're not going to cut yourself. You'll also need to have a pencil, okay. A pen is also okay. Then the last material that you require to have is a sellotape, okay. A sellotape or a double-sided tape as well is fine.
This, a cardboard. aside from that, satellite that are launched into space. And look at which is coming along in that. And that's coming along better than you. Just oh, be a
You do that using your selector slowly at the end you will have a very smart structure subsystem of a cube satellite having been wrapped using a foil paper. Okay, so once you do that, you are done with the structure. And you will have something like this. Okay, so this is one side of your solar panel, so you will require to have two of these. Okay, so you will repeat the steps from the beginning, cutting the cardboard into a rectangular shape, and then covering it using a A4 sheet, and then drawing a rectangular shape 3, and then you start shading them. Inside you have two of them. So what you are going to do is to put your screw into the hole that you have created on one side of the cube satellite, and at the end of the day what you're going to have is the structure subsystem of a cube satellite having a solar panel for you, at least it can be able to generate power for you. So this is for one side, and then you can have another design, a different solar panel on this other end, and voila, there you go, having your cube satellite structure subsystem with the solar panels on the side.
So that's the end of our presentation. I can see a few questions on the chat. Faith asks, so the CubeSat can't work if it's too hot or too cold. Yeah, there are parts of the CubeSat that can't work when it's too cold or too hot. And most importantly, especially the payload. Some payloads need to work at just a certain temperature. So it's the work of an engineer or the thermal engineer to make sure those parts of the CubeSats are just hot enough or just cold enough for them to work. And most electronics don't work when they're too hot or when they are very too cold. So yes. Jasmine is asking, is there any satellite that has been launched in Kenya to learn and explore planets? So far we have 2 satellites, Taifa 1 and 1 Kunz. We are hoping very soon, with the help of the government, Kenya Space Agency will be launching new satellites very soon. It's in our prayers. So yeah, Kenya has launched 2 satellites. And by the way, back in the 1990s, with the help of the Italian Space Agency, we used to launch rockets in Malindi. So maybe in the future, we'll be able to launch satellites using our own rockets, hopefully. Yes, Jasmine will be sharing the link of the video on our Kenyan Space Club on YouTube. We'll provide the link. Emmanuel Gidinji, for students wanting to do a project on satellite data analysis, can they get data from you? Yeah, I'm sure you can get data from Kenya Space Agency. Contacts are on the website link. You can just give an email and someone will be able to serve you. I hope I've answered your question, Emmanuel. And I'm also encouraging anyone, if you have any question, kindly, you can type it or you can ask. Susan, kindly give Susan the mic.
Okay, hi. Can you hear me?
Hi, Susan, we can hear you.
Oh, I wanted to ask, if you don't mind, could you repeat the point where you're talking about Nakuja and no Taifa, sorry, Taifa, the satellite, and there's a point you reached and talked about Kenya not having the specific engineers for something. It didn't like get you. Can you like kindly, if you don't mind, repeat that part?
Yeah. For you to build a satellite, once you've built it, you've designed it, and everything is working, you've tested it. The satellite needs to be certified by an external vendor so that SpaceX can have confidence. Once it's in its rocket, it won't spoil the payloads of other satellites. So at the current moment, Kenya Space Agency or Kenya doesn't have a lab for it to certify satellites. So we pay for such services to other vendors.
Okay, thank you. And
yeah,
is there a reason as to why there's a comment someone made on the chat that currently the launch site is not in service? Is there a reason as to why the Malindi launch site is not in service?
Yeah. With a little history, when the Italian Space Agency were launching rockets in the 1990s, they realized that these rockets were really expensive. So that site was closed. From I think 1991 until then, we haven't been able to launch a rocket into space from Malindi. But at the current moment, Kenya Space Agency is working really hard to make sure that we have our own launch sites, and the engineers are on their table sweating to make sure that at least we have a launch site. Because at the current moment, and with the current technology, it's cheaper to launch rockets from Kenya since we are at the equator. So I'm hopeful that very soon we'll be launching rockets. I hope I've answered your question,
Thank
Susan.
you. Yeah, you have. Thank you.
Welcome. Jasmine, where can you find Kenya Space Agency headquarters? In Pitman Road, there's a building called Pitman House. That's where Kenya Space Agency is located. Faith, do you also teach how to code and engineer robots as in CubeSat and rovers? Yeah. There's an outreach headed by our fellow scientist, Joanne. She does outreach in schools. She does outreach all over the country. She has a team of special engineers and scientists that teach about robots and coding. Yeah, Jakaya Kikwete, Pitman House. Jasmine asks another question. Is there a satellite that is controlled by AI? To some degree, yes. There are specialized satellites that use machine learning to just take images or operate in space, but not fully AI, because we currently, at the current moment, with the current technology, we do not have the power to launch big satellites with AI. So yes, there's a bit of machine learning in satellites. I hope I answered all questions. Or Emmanuel asked for students wanting to do a project on satellite data analysis. Can they get data from you? Oh, I've already answered that. Any more questions? I encourage you more questions. So I think that was my presentation. I hope you learned something. I hope I inspired something. I hope I ignited a fire in you to learn about CubeSats in space. So I humbly hand over the session to Joanne.
All right. Thank you. Thank you, Evan.
Sorry, Joanne. There's a question by Lethiwe Mwenda. What led you to become an engineer? I was interested in science since primary school. I used to do well in science, so I thought there was nothing else I could do other than engineering. So it starts back in primary school. So that was the only thing I used to do well, sciences and math. I wasn't good in languages or anything, any other thing. So that's how I became an engineer. Can a satellite be made of different materials? I doubt, but with research, maybe we can build with more materials. But at the current moment, there are standard materials used in creating satellites. So back to you, Joanne.
Okay, thank you, Evans, for quite an informative session. I hope each and every one of you has grasped something on CubeSat Life. Yeah, and even how to model one at home. Yeah, as we look forward to you being an engineer and modeling a real one that can take you to space. Yeah, so thank you so much for gracing us with your presence. Yeah, we hope to see you again on 28th of September when we shall be having another session. Yeah, talking about space. Yeah, Maureen has a question. Yes, Maureen. Maureen, your hand is up. Maureen, can you hear me? You can unmute if that's possible on your end. Okay, let me have someone unmute you. Okay, you can type your question in the chat. Okay. Okay, anyone else with any clarification they need? Any question, comment, feedback? As we wait for Maureen's question. Oh, it's Moaz. Moaz is asking, is there, I guess that is launching island in Kenya or in Kenya? Sorry.
At the current moment, we don't have an island that's used to launch rockets to space. I think that's what you're asking. So there's no special island. To Maureen, yeah. So there are the engineers who are working on Taper 1 currently, and it's been successful. Yeah. So at the current moment, I'm not part of that team. I cannot tell you what Taper 1 is, what the data is being used for, but it's currently being tracked, and we are talking to Taper 1. Yeah, George, can the presentation be shared in YouTube for those who missed? Yeah, we have Space Club on YouTube, Kenya Space Club, and we share all our webinars there. So this will be shared there.
Jasmine has a question also.
Jasmine is asking, I also learned from my ICT teacher that there's a certain network created by satellites. May I know the name? I'm not sure what you're asking, but when you watch a football match using DSTV, that's actually a satellite network. The video images are published onto a satellite in space, and it's pushed back to your satellite dish. When SpaceX is launching Starlinks, that's a network of satellites that help spread internet all over the world. That's a network. And there's also the GPS. The GPS is a connection of different satellites that helps determine your location of devices all over the globe. I hope that answers your question. If it's an internet network, yeah, satellites help provide internet all over the world. And SpaceX is a good example.
All right, thank you. Thank you, Evans, for those brilliant answers. Yeah, so 3:34. I just want to say thank you for being here and for learning one, two, three things about CubeSat Life. I hope you're going to talk to your friends and your school about KSA, and we can see how we can come and do a more, I'll say words, where we involve more of your classmates in the outreach rather than just you. We have more people participating in the outreach. Yeah, wherever you are in the country, will come. So other than that, I will love to close it here if there is no other question. Thank you so much. Yeah, we will share the presentation and the video, which is in the presentation, to your email. Thank you. Till next time, bye-bye.